Would you expect the second electron gain enthalpy of oxygen as positive, more negative, or less negative than the first? Justify your answer. Very interesting question. O minus, sorry. First you have O gas giving you O minus gas on gaining electron. This is electron affinity, the first electron affinity. And then you have O minus gaining one more electron to form oxide ion. This is second electron affinity. Is the second one more exothermic, less exothermic, or even endothermic? As a matter of fact, first electron affinity. As a matter of fact, first electron affinity of oxygen is quite strongly exothermic. Oxygen loves eating away one electron and forming O minus. But always remember, you might feel very motivated to see that in this case there is a noble gas configuration. So students normally tend to feel that because oxygen is forming a noble gas configuration, it should release even more energy. Agreed, this was one factor. But don't you forget that amongst them, the most major factor is electrostatic repulsion. There was zero charge and electron came and formed O minus. So this is exothermic or negative. On the other hand, if you have O minus giving you oxide ion, this second electron has to enter O minus against the electrostatic repulsion of first electron, and this electrostatic repulsion becomes the most major factor, so much so that it becomes strongly endothermic or positive. Second electron affinity. They said, would you expect the second electron gain enthalpy of O as positive? Yes, it is expected as positive, while the first one was actually negative. And it is so positive that overall reaction, if you add up EA1 plus EA2, this also is endothermic only. First is exo, second is endo, and second is so much of endothermic that overall reaction also becomes endothermic only. It is a fact which I am sharing with you so that you can mentally arrange the level of importance. Yes, noble gas configuration is important, but more important is electrostatic attraction or repulsion. That happens to be the major contributing factor.